Now application 3, he said consider a particle m moving in a circular motion with an acceleration a equal to 5 unit normal meter per second square, with un is the unit vector along the normal axis. From here, you can discover that since no unit tangential then the motion is uniform circular. The radius of the circle is 20 centimeter. Let me write the given that A equal to 5 unit normal, and the radius is 20 centimeter. 20 divided by 100 is 0.2 meter. This is application 3. In part 1, he said, prove that the tangential acceleration is 0. Since A vector equal to A u tangential plus A normal, u normal, and only the acceleration is 5 along un, then A tangential equal to 0. There is no ut here. Then A tangential equal to 0. Part 2. Determine the value of the speed of m. Since the only available here is u normal, I can use the formula an equal to v square over r. Okay, let me write it. Since a normal equal to 5 and a normal equal to v square over r, then v square would be 5 times r, and by removing the square I have to put radical 5. The radius is 0.2, which will be 1 meter per second. Part 3. Calculate the angular speed and the angular acceleration. The angular speed, let me write it here. Part 3. The angular speed is theta prime. I can find it from v over r. V was 1 and the radius was 0.2. The answer is 5 radian per second. And the angular acceleration is simply the derivative of the angular speed, and the derivative of constant is 0 radian per second square. Part 4. Specifying the type of motion. I can justify by 2 methods. The motion is uniform circular motion. Since I have 3 methods, in fact. Since the acceleration is along the normal only, I can specify by that. Or since the angular speed is constant, I can answer by that. Or since the angular acceleration is 0, one of them. I will choose the most easiest one, the angular acceleration is 0, and this application is done. Application 4. He said consider a particle S moving in a plane according to the following position vector r equal to cosine t along I plus 2 sine t along j. Determine the equation of the trajectory of S. We did that before. This is application 4. The equation of a trajectory, since the position vector r equal to cosine t along I plus 2 sine t along j, then this is x and this is y. I have to find the relation between x and y. X is 2 cosine t and y is 2 sine t. And the relation between sine and cosine only confounded by Pythagoras. Cosine square of angle t plus sine square of angle t must equal to 1. I have to take the cosine from here and the sine from here. Cosine of t here will be x over 2. And the sine of t will be y over 2. I will substitute them down. This is x over 2 all of its square plus y over 2 all of its square equal 1, which means x square over 4. I can multiply the whole equation, by the way, by 4. Plus y square over 4 equal 1 multiplied by 4, x square plus y square equal to 4. He said in part 2, deduce that the motion of S is circular along a circle whose center and radius to be determined. Since the equation x square plus y square equal to 4 is similar to x minus a all of it square plus y minus b all of it square equal to r square, then the motion is circular, then the motion is circular, and the center is the origin itself, because here if I make them similar it will be x minus 0 square and y minus 0 square. The center is the origin O itself, O 0 0, and if r square equal to 4 and radius, the radius is r equal to 2 meter. Part 3. He said calculate the velocity of S, then deduce its algebraic value. V is simply, this is part 3. V is simply the derivative of r vector. And the derivative, don't forget that the derivative of cosine is minus sine. So 2 is not touched. The derivative of cosine is minus sine t along I plus. The derivative of sine is cosine. 2 untouched cosine t along j. It will be minus 2 sine t along I plus 2 cosine t along j. And he asked me about its algebraic value, v equal to the radical of vx square plus vy square, big radical, the square of minus 2 sine t all of its square plus 2 cosine t all of its square equal to radical of 4 sine square t plus 4 cosine square t. Take 4 as a common factor. Sine square of t plus cosine square of t, this totally will equal to 1. So it's radical 4, so it's 2 meter per second. This motion, by the way, since the speed is constant, this motion will be a uniform circular motion. Part 4. Determine the acceleration, the normal acceleration, and the tangential acceleration. Okay. The acceleration, this is part 4. The acceleration is the derivative of the velocity. The derivative of sine again is cosine. So it will be minus 2 untouched cosine t along I plus 2. The derivative of cosine here is minus sine t, minus sine t along j. Little arrangement. It's minus 2 cosine t along I minus 2 sine t along j. And don't forget in each time to say SI unit. Here I forget it too. The normal acceleration. The normal acceleration is simply v squared divided by the radius. V, I have it to be 2, and the radius, I have it also to be 2. So 4 divided by 2 is 2 meter per second square. About the tangential acceleration, and he didn't say the value, so I have to write a vector here. A normal vector is 2 meter per second along the unit normal. And about the tangential now, tangential is the derivative of the speed along unit tangential. And the derivative of the speed is 0. So it's 0 vector. Now, he said specify the type of motion of S. Since a normal is constant, you can say directly that, or the acceleration is along the normal, you can say that the motion is uniform circular motion, or you can use the speed. Any one is good. For uniform circular motion, since the speed is constant, the speed is constant, and the trajectory is circular. The trajectory is circular, and the problem is done. Thank you.